Go. Ooh.
Hello, I'm Hans, and I'm going to teach you quantum physics. I'm going to show you how to find the color, if there is any, coming from the heated up helium right there. And then I will find it.
You will what?
Find it.
You'll find it. Okay, how are you going to do that?
Well, I'll need to find my frequency and then my wavelength.
Of the emitted light, right?
Yes.
Okay, so how are you going to find the frequency and wavelength of the emitted light?
Well, I need to find my frequency first.
Uh-huh.
To find frequency, you do frequency equals E divided by H. This is like it's not how it was before.
Anyway, okay, so what do you need to find?
Energy.
Okay, so you need to find energy in order to figure out the frequency, right?
Mm-hmm.
Okay, and then so what are you going to do?
Your En equals Z squared divided by N squared times negative 13.6.
What's Z mean?
Z, it means the number of protons.
The number of protons. Okay, so
And
you're talking about...
the principal quantum number.
Okay.
And then I'm doing from the E2 right here.
Uh-huh.
The energy level E2 to E1 for the first one.
Okay.
So E2 to for E2 I got 13.6 eV, and for E1 I got negative 54.4 eV.
Okay, so what do you do after you calculate E1 and E2?
Find your delta E.
What's delta E?
It's your it's because from here to here, the leftover part, from this minus this.
The leftover energy, you mean?
Yeah.
Uh-huh.
It turns into like light.
Okay.
So that is the energy of that light.
The light released.
Yeah.
Okay.
Light released. So it's.
So how much is your delta E?
40.8 eV.
How did you calculate delta E?
The E2 minus the E1.
So do you use higher energy level minus low energy level, or do you use low energy level to minus higher energy level?
Higher energy level minus lower energy level.
Okay, so your delta E was found to be how much?
40.8 eV.
Okay, did you do this calculation yourself?
Yes.
Okay, so so what's next after you find? So what is delta? Okay, so delta E. You found delta E. What's next?
Well, after that, you need to find frequency.
How do you find frequency?
Frequency equals energy divided by the Planck constant.
Okay.
So the frequency is 9.86 times 10 to the 15th.
Okay, you don't need to go in a specific number, but what formula do you use in order to find, once you know the energy, how do you find frequency?
Frequency is E divided by H.
E divided by H. What's H?
Planck constant.
Planck constant. Okay, very good.
So next you need to find your wavelength.
How do you find your wavelength?
So C equals F times wavelength.
Okay.
Move it around.
Lambda. Okay, wavelength. What's C?
C is speed of light so you move it around to speed of light divided by frequency equals
That give you wavelength. How much was wavelength you found?
0.304 times 10 to the negative 7 tower meters.
Okay.
And then I need
what do you
to
need
turn
to
it into nanometers. Oh, this part is so
Why? Why do you need to turn into nanometers?
Because to find the color, it's all nanometers.
Okay. Okay. All right. Okay. So how did you turn meter into nanometers?
So you do 0.3 times 10 to the negative 7th power meters times 1 nanometer over 10 to the negative 9th meter. The meters cross out, and the 10 to the negative 9th power flips, and it becomes 10 to the 9th power.
Okay, let me ask you, 1 nanometer divided by 10 to the negative 9, 10 to the negative 9th power meter. What does that equal to? 1 nanometer divided by 10 to the negative 9th meter.
It is...
What does that equal to? Equals?
It is 10 to the 9th power.
No.
No, what? No, that's wrong.
Equals 1.
1, right? 1.
Right?
Yes.
That's why you use it, right? Okay, because is 1 nanometer the same as 10 to the negative 9th meter?
Yes.
They're the same.
Yeah, it's 1. It's
So
1.
so 1 nanometer divided by 10 to the 9th power meter equals?
Equals 1.
1, okay? That's
So-
why you multiply that,
So anyway,
okay?
it's point...
So what's your
I ended
answer?
up with 0.304 times 10 square, which is 30.4 nanometer, which is...
Which
what
is?
color is it?
So what's the range of visible light? What's the wave?
360 nanometers to 830 nanometers.
Okay, so in this case,
Oh, no. It's not a color, it's ultraviolet.
how do you know it's ultraviolet?
Because anything, all the numbers from 360 to like 10 are ultraviolet.
Ultraviolet. So does that mean it has more energy or less energy than visible light?
More.
Huh? More. But the wavelength is smaller, so how can it have more energy?
It doesn't matter it needs a bigger frequency.
Okay, so if
And usually if the wavelength is bigger, the frequency is smaller. So the bigger wavelength you have, the less frequency you have, so the less energy you have.
Oh, I see. That's very good. Very good. Okay, so good. So there is no visible light, right? When you heat a helium gas?
Wrong. There is.
There is? How?
Yes. From the 4th to 3rd.
Okay, fourth energy level to the
Fourth
third.
energy level to 3rd energy level.
You think there would be visible light? How do you calculate? How do you find out that there was visible light?
Well, there
Can you
might
tell
be.
us the work that you did there?
Well, I found the 3rd energy here.
Okay,
Which
E3.
was,
Energy of the third energy level, E3.
Negative 5.98 eV, and the 4th one was negative 3.4 eV. And the delta E was 2.58 eV.
Okay.
So next you need to find your frequency.
Mm-hmm.
So the frequency is 0.623 times 10 to the 15th power per second.
Okay.
And then you need to find your wavelength.
Mm-hmm. How do you find your wavelength?
What's it? Oh, here. The speed
Okay,
of light, which is 3 times 10 to the 8th power meters per second divided by the frequency is 4.82 times 10 to the negative 7th power meters, and then you.
So
and then
that's
you have
that's
to turn it
your.
into nanometers.
Okay, so that's your wavelength. Okay, so and then.
And that's 482 nanometers.
Okay.
Which is. Oh, it's in it.
So it's within the visible light,
yes,
right?
It's within the visible light, and it's light blue.
And it's light blue. How do you know it's light blue? We check out
checked on the internet.
the spectrum, right?
Mhm.
The visible light spectrum. We found it to be light blue. So when you heat up like helium gas, what kind of color would you see?
Well, you would see light blue.
Light blue. Okay. So did you do all this calculation yourself?
Yes.
Oh, very good. Good job. Do you like physics?
Mhm.
Why do you like physics?
It's fun.
Yeah?
Yes.
Do you like math?
No.
Do you like writing?
No.
Do you like piano?
No.
So, is there anything you like?
Physics.
That's it?
Wrestling.
Wrestling? Okay. All right. Good job, Hans. That's amazing. So, what did you teach us today? What's the subject you taught us today?
The quantum physics and the what color the light is coming out from the heated helium.
Okay, very good. Good job.
Bye.
Bye.